Okay, so next time is the test, so you need to make sure that you've gone through everything. We're going to go through an electrochemistry review today. Last time we did the nuclear chemistry review. Remember, the nuclear chemistry on the test is going to be the multiple choice. Make sure you know how to do half-life and all that stuff, but it is going to be on the multiple choice. The electrochem that we're doing today is going to be the written part of the test, so you need to make sure you listen to that and do what you need to today. I'm actually going to use the part in your handout that you got at the beginning of the unit as the review notes, and then the paper that you picked up today is going to be your assignment. So if you would get to your electrochemical review, I will put that up here, and you can go back and look at any of them. Test is next time, so make sure you're ready to roll there. Okay, so what we're going to do is we're going to go through the review from your notes, and I'm going to give you the answers to that. There's no points possible on this. Like I said, we're changing that up. I didn't like that part of it. We're going to do the paper that you handed out. We're also going to do a couple from scratch so that you can get used to what will be like what is on the test. Okay, so first of all, number one here, what is the oxidation number of chlorine? In order to get the oxidation of chlorine, you have to realize that hydrogen is a +1, that chlorine has many different charges, and we don't know what it is, and that oxygen is a -2, and we have 4 of them. So we end up solving for this equation here, and that gives us x minus 7 equals 0, so x is +7. So that is the answer for that one. On this one, you're looking for the oxidation of carbon. You have 2 carbons, which we don't know the charge of, but we do know that there is a +1 for each of the hydrogens. So then we get 2x plus 6 equals 0, so each x is a -3. A battery is an example of an electrochemical cell that is a voltaic or galvanic. The other word for that is galvanic cell. That means it's going to give off voltage. Okay? I'm going to enlarge that a little bit so we can see that a little bit better for the back of you. So it is an electrochemical cell, and it's a voltaic or it should be a voltaic or galvanic cell. If I'm given this reaction right here, I've got to realize that this right here is a Cu +2, and this right here is Mg +2. The SO4 is like a spectator; it doesn't really do anything. I need to realize that going from one side to the other, magnesium goes from no charge to a +2 charge. That means it's lost electrons, LEO. Loss of electrons is oxidation. Copper, on the other hand, has gone from a +2 to a 0, so it has gained electrons, GR. Gain of electrons is reduction. So if it asks what oxidation is, it's this. If they ask what reduction was, it would be number 3. Okay? So same thing is going on in the next one. In the following reaction, we've got Fe going to Fe +2. That's LEO, loss of electrons, oxidation. Zn +2 going to zinc is GR. Gaining of electrons is reduction. Now, remember on this one, when I talked to you about the wedding, having a bride and a groom. If I'm the bride, then I'm the groom agent. If I'm the groom, then I'm the bride agent. I can't be a groom or a bride without the other person. Okay, so here Fe is oxidized, and zinc is making Fe oxidized, so it's the oxidizing agent. Okay, so here it doesn't say reduced and oxidized; it's reduced or oxidized and the agents. So you got to just remember, if it would have been reduced, it would be the oxidizing agent, opposite. Okay, on the next one right here, we're looking at the oxidation charge that has a -1. Well, in most of these I can look and say, oh yeah, oxygen's a plus or -2, 0. The only time it can be a -1 is if it's forced to be with the first column. It will, except for hydrogen, will force it usually to be peroxide, which is what's happening there. Elements that readily gain electrons. Okay, if it gains electrons, those are going to become negative, right? So on the periodic table, the ions that become negative are on the right-hand side of the periodic table. On the right-hand side of the periodic table, they're really close to being a noble gas. So trying to take away an electron, which is ionization, that's going to be really high because they don't want it to go away. They want more. The electronegativity, fluorine has the highest on the periodic table, so it's going to be really high. So high ionization energies and high electronegativities if I'm gaining electrons. Okay, electrochemical cell, the cathode, red cap pause. Remember that, red cap pause, that's the positive side. It's the cathode, and it's where reduction occurs. On number 9, what the purpose of the salt bridge is so that we can move charges from one side to another, so we can balance out the charges. So to provide an electron flow between the two half cells of the electron current. Actually, it should be, nope, that should be 4. To provide ions flow. Sorry, I screwed up on that one. That should be number 4 because it's the ions that move through the salt bridge. The electrons move through the wire, right? Okay. Number 10, what is not the same for voltaic or electrochemical cell and an electrolytic cell? Electrolytic cell needs electricity. A voltaic cell gives off voltage, or electrochemical cell gives off voltage. They don't both produce voltage and an electric current. One of them needs voltage. Okay. On number 11, the key here is if I have an element by itself, that charge is 0. When it goes into a compound, it becomes a charged element. So if I have an element and it goes into a compound, then I have a redox reaction. That's the fast and easy way to do it. We're not going to worry about number 12, so go ahead and pass that out. Number 13, we start talking about a battery again in diagrams. Now, you'll notice here that I've put both of the equations together right here. Okay? So you need to be able to take the two equations and put them together. Basically, you just make sure that the electrons balance. If they don't, then you times an equation. I'll show you how to do that in just a minute. So, when the switch is closed, which electrode becomes heavier? Well, if I look at this, Pb is going to Pb plus 2, so it's coming out into solution. And Cu is becoming Cu metal, so it's going on. So the copper electrode is becoming bigger. The next step is which direction will the electrons flow? Well, if this is coming off into solution, then the electrons come off of that and come over to the other side. So that was A. And number 15, which metal ion will increase in concentration? Well, I'm putting more Pb plus 2 into solution. I'm taking Cu out of solution, so it's a Pb plus 2 that becomes more. And what will increase the voltage and current of the cell? The only thing that will increase the voltage is to increase the concentration of what it's in. That's the only thing. Okay? So that's D on 16. Number 17, we get to electroplating as an example of what? An electrolytic cell. That's the one that needs electricity. Number 18, the total electrons. Well, if I look at here, I've got 2 chlorines going to 2 chlorines, and I know chlorine goes from a -1 to a 0, so that's 2 electrons that are moving there. That's why the 2. On number 19, we go from what is the reducing agent, so that would be what's oxidized, becomes more positive. Magnesium goes from 0 to plus 2. In the next one is a chemical reaction. What is conserved? Both charge and mass. So I've got to have the same amount of charge and mass. Don't worry about 21 through 24. Just cancel those out. 25, we start looking at another cell. Now again, the nitrates here are spectators. So I have to say, oh, that's a Zn plus 2 and that's an Mg plus 2. So I can see what's happening. So Mg is going to Mg plus 2. So that's going to be on the anode side. That means my magnesium is coming into solution. Magnesium ion is coming into solution, and the electrons are coming off of that. That also means that the zinc is being plated out. So my anode oxidation negative on this side, cathode reduction positive on this side. Remember the little phrases will help you. An ox negative. It's a negative experience to be run over by an ox. Anode oxidation negative. Red cap pause, reduction, cathode positive. And the electrons always move from the anode to the cathode. Anions move towards the anode. Cations move towards the cation. Okay? For that, you do need to have the half reactions. So you need to realize that zinc is gaining 2 electrons to become zinc metal, making that electrode fat. And magnesium is coming off of the metal into solution as Mg plus 2 and giving off 2 electrons. Now, to add those two together to make that equation, notice that I have 2 electrons and 2 electrons, right? So they will cancel out because the arrow's like my equal sign. So the overall reaction, if I were to write the overall reaction, I'm just going to do it over here on this side, would be Mg plus Zn plus 2 goes to Zn plus Mg plus 2. Now, if one of these happened to be a 1 electron instead of 2, say this one was a 1 electron, all I would do is put 2's in front of these and put them into the main equation again. That's it. I don't do anything with the voltage, though. The voltage I just add. I never times the voltages. Okay? So on the second cell that we've got down here at the bottom, this is an electrolytic cell. So that's A on 32, electrolytic. And you'll notice that with the electrolytic cell, we've got a silver electrode right here, and we have silver being plated on an object over here. Notice there's no salt bridge. The solution is the same. That's because I'm taking the metal out off the electrode into solution, and I'm putting it onto something else. So if I want to chrome my bumpers, I take it to some place that has chromium in a solution, and they can dip my bumper into that and run an electrical current through that so that I can get chrome on my bumpers. Okay? Same thing happens with when I want to silver plate anything like jewelry. This is how they do it. Okay? But I have to have a current source, either a battery that's right here, and oftentimes batteries are written like this in writing it, or I have some kind of electrical current, like I've plugged it into the wall. So on this one, it asks what equation is happening at each side. You'll notice that here I am being oxidized, and here I'm being reduced. But it's the same equation. One's just backwards of the other. So in D, it asks, in what 2 ways does this cell differ from the one we have usually studied? The first one is it has to have a source of electricity. It has to have some source of energy. And the second one is I only have one solution. I don't have 2. Just have one. Okay, because I'm taking it off as a metal, putting it into solution, and plating it on something else. Okay? All right. I believe that's the end of that one. What I'd like you to do is get out just a blank piece of paper, because we're going to do a cell just from scratch, like you're going to have to do a couple times on the test.
Okay, what should we study for the test? I don't know exactly what.
So I went through the review for the nuclear, so you need to be able to do your equations for nuclear to find your half-life, to be able to find number of half-lives, to be able to find the amount initial, amount final, be able to write nuclear equations, know your alpha, beta, gamma symbols, and how to write the equations. And then you're going to need to be able to do batteries. Okay? So, all right, so let's set up just a basic battery. So here we have a cell part, and here we have another cell part. Whoops, that one's really big. And I'm going to have electrodes in here, right? I'm going to have a salt bridge. These are all basic. We've been doing these in our dry battery lab. The electrodes have to be connected through a voltmeter. I can put that up there.
You've obviously done this one once.
Well, these are things that we've just been drawing, right? That's just a basic battery setup. I haven't told you what battery we're doing, but this is what it's basically set up. Right? I want to have my anode, which is where my oxidation occurs, and it's my negative side of the battery on this side, just so that I'm in constant doing what I'm supposed to be doing. On this side, I'm going to have a reduction. This is my cathode, and this is positive. Now, if I do that, then I know the electrons have to flow this way. I can put those on. I haven't even chosen what things I'm going to put in there yet, right? I can also already put in this. This is anions going this way. And this way I'm going to have cations. I know this side's going to get smaller. I know this side's going to get bigger. All that before I even decide what elements I'm going to use for the battery. Okay? Now, for the battery, say that I gave you let's do, let's do 10 to 10 plus 2, and magnesium to magnesium plus 2. So I'll often give you a symbol like this. Basically it says this is one half cell, this is the other half cell. The two lines in between just say that's the salt bridge. They're connected. Okay? I have not told you which one's going to be on top, which one's going to be on the bottom, anything about it. But I've given you the two elements and what ions they're going to. Okay? So now we're going to grab our chart that we have like this, and we're going to find these two on them. Remember, the lower one goes to the left, and the one that's right goes on the right. The top one goes on the right. So find tin, find magnesium. Which one is on top? Tin. So I'm going to take, and underneath right here on this side, I'm going to write tin's equation just like it is. So Sn plus 2E minus yields Sn and negative 0.14. And just to make it so we can do something, I'm going to change that magnesium to sodium. Sorry, I'm going to do sodium because we're going to do something different with it later. Sodium's still down below 10, so we're okay. So we're going to find sodium. I'm going to go out a little bit. You guys find sodium down at the bottom? Okay, but we're going to flip, we're flipping it around. So Na is going to go to Na plus E minus. And the voltage is also going to change signs. So I'm going to have a positive 2.71 volts. Everybody okay with that? Now I can fill in the rest of the stuff here. The electrode is going to be sodium, and the electrode over here is going to be tin. Over here I'm going to have sodium coming out into solution as Na plus. Over here I'm going to have tin plus 2 going out of solution onto the electrode. I also forgot to label my salt bridge. Okay, now I can quickly find my E cell by just adding these two together. Now that I've already changed the sign, I'm just going to add them together. And I will get my brain today. I'm just going to use the calculator. 2.57, it's a positive volts. So that's how much voltage my cell is going to be. Now, on your worksheet, you also need to take these two and put them together as one equation. Okay, because these are half reactions. Notice on this one I have 2 electrons, on this one I only have 1. So I'm going to need twice as many of these. Okay, so I'm just going to put 2 in front of those. So I'll go 2Na plus, what's on the reactant side over here, Sn plus 2, arrow. Then what's on the product side? Remember I put a 2 in front of the side, so 2Na plus Sn. These would be solid, and these would be aqueous. And I'm done. I've done everything I need to. I can also redo the battery notation from that and say, oh, Na, which was on my left, goes to Na plus salt bridge. Sn plus 2 goes to Sn. So that's the correct battery notation for that battery. Okay, you need to be able to do that. So on your problems right here, I've got you a whole bunch of new problems here for you to go through and try. The front side, you don't have to draw any batteries. Back side, you do. So you're going to have practice drawing the back side, and you're going to have practice doing some quick ones on the front. Yes, sir? This will be the written part of the test. So I've given you an example of what you'll see for the written part of the test. Remember, the multiple choice will be the nuclear, so you do need to know a little bit about that. Yes?
Do we get to use these on the test?
There will be that on the test for you, yes. Okay? Any other questions? Yes, ma'am. This way, you mean? For me, that's down. How far down? Okay. All right, so time is yours to work on this. If you have questions, please come up and do it. We will correct this assignment right before the test next time. Okay? Right before the test next time.
Wait, what's our multiple choice?
Multiple choice will be the nuclear chemistry.
So like
So the half-lives, the alpha, beta, gamma,
the stuff that you just like write out, like whatever the element is, and it's like.
So I'll give you an equation and say what's the blank supposed to be.
Like, if it decays or like.
Yep, I think they're back in lab.
Bombards or whatever those ones.
Yeah. Yep. Okay, any other questions? Yes? Oh, we need to correct the other assignment really quickly, the nuclear one. Let's grab that out real fast. We'll correct that.